Lesson 3-3, solving equations by creating equivalent equations. The big idea is performing the same arithmetic operations on both sides of an equation can create an equation that is easier to solve. So, in essence, this is our regular algebra. What you're going to find out is Mr. Johnson, on the equal sign, he considers this the left side and the right side. And in order to keep these things equivalent, whatever you do on the left side, you have to do on the right side. Whatever you do on the right side, you have to do on the left side. Depending on what you need to do is dependent on wherever the variable is at. Okay? And then we use algebra to undo it. So this is algebra that you've been doing for a long time, and all we're doing is inverse operations. So it says from the original equation, two more equations are formed. If you look at this, 11 equals 4x plus 3. So what they did here, the inverse, they noticed that on the right-hand side is the variable x. So they want to get x by itself. So the first thing they needed to do was undo their addition or subtraction. So the inverse of adding 3 is subtracting 3. Whatever you do to one side, you have to do to the other. 11 minus 3 gave you 8. 4x plus 3 minus 3 leaves you with 4x. Leaves me with this equation. Now I still need to get x by itself. So the inverse of multiplying by 4, because side by side means multiplying, is dividing by 4. Whatever I do to one side, I do to the other side to keep it equivalent. 4 divided by 4 is 1. 1 times x is x. 8 divided by 4 is 2. So my solution, now that I got x all by itself, is 2. Can you check that? Yes. If I put 2 in here, 4 times 2 is 8, plus 3 is 11. Does 11 equal 11? Yes, that checks out. Therefore, we have a solution to our equation. These three equations are called equivalent equations because 2 is the solution to each of them. Equivalent equations are equations with exactly the same solutions. Okay? All these are equivalent because they have the solution, which is 2. Let's look at this problem. Same type of problem. Find out where the variable's at. Well, the variable is on the left-hand side. Okay? So the first thing I got to do is I got to undo my addition or subtraction. So the inverse of subtracting 12 is adding 12. And sometimes what I'll do is just make a river here, and you can do that just to keep your sides in check. So if I add 12 on the left, I have to add 12 on the right. This just keeps it nice and orderly so you can see what you're doing. Well, a negative 12 plus 12 leaves me with just 8x on the left-hand side. And 4 plus 12 gives me 16. Still got to get x by itself. The inverse of multiplying by 8 is dividing by 8. Whatever I do to one side, I have to do to the other. My 8's will divide out, leaves me with x. 16 divided by 8 is 2. So 2 is the solution to my problem. Now, can I check that? 8 times 2 minus 12, does that equal 4? Well, 8 times 2 is 16 minus 12. Does that equal 4? Yeah, 4 equal 4. Yes, it checks out. Moving on. Solve each question using your CAS. We don't use this. We can do it by hand. 4/7 z plus 2/3 is equal to 1/7. Same process, don't panic. Now you're just dealing with fractions, okay? So here's my variable. It's on the right-hand side, correct? So I got to get everything else out. So the inverse of adding 2/3 is subtracting 2/3. Whatever I do to one side, I have to do to the other side. Now with fractions, what has to happen is you got to get a common denominator. Okay? This has 7, this has 3. What will 7 and 3 go into? Most of you are saying 21. Or hopefully all of you. Okay? So, what times 3 gives me 21? 7 does. So, if you multiply this by 7, you have to multiply this top by 7, the numerator. A negative 2 times 7 is a negative 14. What times 7 gives me 21? 3 does. Whatever I do to the bottom, I do to the top. 1 times 3 is 3. So 3 21st minus 14 21st is a negative 11 21st. My 2/3 are going to add out, leaves me with 4/7 z. Now, as I told you in a previous lesson, when I see stacked numbers here, the easiest way to get rid of this is to multiply by the reciprocal. The reciprocal of 4/7 is 7/4. Whatever I do to one side, I have to do to the other side. So I multiply this over here by 7/4. My 7's divide out, my 4's divide out, leaves me with z, which is what I want, equals 7 goes into 21 3 times. 7 goes into 7 once. A negative 11 times 1 is a negative 11. 3 times 4 is 12. So z equals a negative 11/12. You can put that back into your equation to see if it works. Won't you pause for a second and try that out? Going on to B. Negative 3y plus 14 equals 98. Left side, right side. Variables on the left side. Got to remove everything else. The inverse of adding 14, subtracting 14. A negative 3y is equal to 98 minus 14 is going to give me 84. Okay, perfect. Now, if you notice here on the left side, I have a negative 3 times y. So, do you need to divide by a negative 3? Yes. Take the negative sign with you. Why we do that is because we want a positive value for y. We don't want a negative y, we want a positive y. So what we need to do is we need to take and divide by a negative 3 because I just want that to be 1y. Those divide out, leaves me with y. And a positive divided by a negative is a negative. You're going to tell me 84 divided by 3 is 28. So my answer to y is a negative 28. That's all I have for you today. Please enjoy. We'll see you tomorrow.